All right. Welcome, everybody. We are going live right now. Welcome to the Turbonomic Labs live event. This is a very, very exciting day for us because this is the first in our series. We've been dabbling with the idea for a while and finally have set things up. So we know that based on requests and people that have talked to in the community and people I've talked to in our customer community that have been very keen on using this kind of office hour style learning where we can actually dive into some really cool technical topics and get into the bits. We're interactive as well, so if you want to reach out through the chat in whatever platform it is that you're watching from, then I'll be able to actually see a live chat, hopefully on what's going on my screen. With that, we should begin. My name is Eric Wright. I'm the technology evangelist and director of technical marketing here at Turbonomic, and I am proudly your host today for Turbonomic Labs. This one is going to be something exciting because this is one of the most hot topics for Turbonomic. And I should give you a quick layout. So on Tuesdays, we're calling these Turbo Tuesdays. Turbo Tuesdays are featuring specific use case exploration around how can you kind of do really neat things with your Turbonomic application instance, whether it's up in the stack, down to the infrastructure, out to the cloud, across your containerized environments, and really kind of diving into the very neat use cases that sometimes we take for granted, that we know all these really cool features and capabilities that are inside the platform, but aren't necessarily widely known in the customer community or for newcomers to the platform. So this is a chance for us to kind of do those things in a really enjoyable and fun style. And it doesn't take away, of course, from our amazing education. So if you are a Turbonomic user today, please make sure you leverage, especially right now in the time that we're going live and shortly after, we're actually offering free Turbonomic ACE education. So ACE is our certification program, and we've got an amazing education team. So if you go to turbonomic.com/education, then you're going to be able to get access to free remote education, which is a beautiful opportunity for us to share with you and make sure we do so safely. So today we're going to explore a really neat use case, which is about what I call superclusters. And this is what our Tuesday events are. And again, don't forget to mark your calendar if you're taking a look. If you're actually on our live page right now, or if you're watching on YouTube or on LinkedIn Live or on Periscope, wherever it would happen to be, then you can also go to turbonomic.com/labs, and then you go to /live from there, and you can actually see all the upcoming schedule. So every Thursday, we're doing open technology. So this Thursday, if you're watching us live, I'm doing OpenShift. With that, let's get started. Okay. Superclusters. This is a really neat concept. And one, again, this has been one of the most profound effects that we've been able to have in environments where we make sure that you're getting more for less, really leveraging the infrastructure and the capabilities that you have in your IT portfolio and making sure that, especially in the on-prem world, that you're using what you got as much as possible. And I'll talk about some very specific use cases that we've actually been able to unlock. And then we're going to dive right into the platform and show you exactly how it's done. It's literally a few clicks, which is kind of crazy when you realize how simple it is and what you're unlocking by doing so. It's this real concept of getting, we call it cloud economics on premises. And really what it is, it's elasticity. So how do you make sure that you can get truly elastic infrastructure? Loved the idea of what we call the SDDC, the software defined data center. However, we've got some practices that we've hung on to for far too long. And this is a chance to surpass those and really get that kind of elasticity. So it's important. Everything we do, we got to make sure we start in the context. If I'm not solving a problem, then I'm doing things just for tech's sake. I'm a technologist and a nerd at heart. I love the idea. I'm wearing a nerd shirt, right? I'm all about making sure that I understand technically what's going on. However, if you're not unlocking a real business challenge, then ultimately you're doing it just for your own intellectual enjoyment. Nothing wrong with a bit of both. So the challenge that we're going to solve, it's very distinct, and I would bet it's a familiar thing to you, having run a data center at scale for 20 plus years before I came to Turbo. I know these challenges because I face them from environment to environment, in every customer environment that I go to, and every community member that I talk to in my peer group. when we go out to the world and go to the VM worlds and go to Ignite and go to all these different events and talk about their on-prem deployments, we see the same challenges today. And that is, we're deploying based on resiliency, but in resiliency, we believe that means overhead. The most commonly misunderstood concept in technology architecture, and believe me, I've been doing this for years, and even sometimes I still struggle with the math behind it. It's what we call N+1, right? When you build a cluster, you architect it for a failure domain. That's really what you're doing, right? You're taking a group of servers and you need to be able to understand what is the maximum amount of failure that you can withstand while still having the remaining infrastructure survive to keep your applications up. So if I think about this, if I burn down 2/3 of my environment, I'm in real trouble, right? Or if it's running hot. So imagine that there's a case where you could be looking and saying that if I have these, 3 out of my 9, if they actually go away, right? What's the impact? So I'm actually moving all the resource utilization to the remaining 6 servers. But the funny thing is that a lot of people still think today that N+1 means I have 8 servers, so I should have a 9th server, and that makes me N+1. So +1 doesn't mean another host. It's actually a calculation. If you're a storage kid and you're familiar with how like RAID and RAID architecture works, RAID isn't just like 3 drives plus 1 means that it's RAID 5. It means that there's striping across the different drives using parity bits. And so in effect, N+1 is like RAID for your clusters. So if you expand your cluster, you can see that, if more outages occur, then you're going to be able to, again, if I were to wipe down and lose access to part of my environment, the remaining part will stay alive, but it's going to be running a little hot. So conceptually, that's good. And I apologize. Like sometimes it seems like real review, but remember, how do we do this, right? Today, this is enterprise architecture in a nutshell. This is what my environments used to look like, and a lot of environments look like. We have purpose-built clusters. So what we'll do is we'll say like, hey, I want to make sure the dev and QA stuff is separated from the rest of the world, so it's protected, and the rest of the stuff is protected from it. We've got our production web servers. So they're, again, isolated. Maybe I've got a DMZ that's pointing into here. So I've got different network requirements. We've got a VDI cluster, especially nowadays with all the stuff where people are suddenly remote. VDI is an incredibly powerful tool for remote staffers. And SQL cluster, right? This is another big problem, a big use case that we're going to talk about, which is licensing by cluster, but giving them standalone resources because it's generally licensing, but also people have this kind of idea that it's performance. So if I'm actually separating my SQL servers, then they're going to get access to those resources. I don't want somebody else stealing those resources. Well, imagine that we could actually dynamically move things around. It's 2020, right? 2020, and we've got vMotion. We've actually got cross-cluster vMotion. We call it vMotion in the same way that I can actually call this a Kleenex, right? It's actually a facial tissue. So it's a live migration, but the truth is we know it by the trade name because VMware effectively created the capability to do live migrations, and it was called vMotion. You probably saw it, back in the day, 2005-ish, I guess, 2005, somewhere in there, 2005, 2006 was the first vMotion. And it was incredible. It changed our lives, right? So we've got this idea we can move resources around within the cluster. Well, then what we have is not just our day-to-day stuff, but those resources also need to be protected in the case of loss. So what we do is we've got our, in case of emergency, break glass clusters, which are sitting in a secondary site. And they may be a one-to-one mapping. Maybe you're actually reducing because not every resource, so you don't need to protect the dev and QA. So there's ways that you can potentially consolidate resources. You may have some prod, live resources on the other side. So there's stuff that could be primary in site B, but secondary in site A. You know what I mean? So the reason why I bring this up is why did we do this, right? We had a functional reason why we separated all of these things. So we got our production web servers. Well, we needed to make sure they were separated. But what do we do? What are we actually aiming for, right? Is it failure domains? Is it performance risk? Is it capacity growth? Is it another logical requirement? And quite often, it's just because it made sense. Seemed like a good idea, right? Like, let's make sure that they're separated. VDI is one of the most common use cases. People love to separate VDI because they're worried because it could impact other resources that are in other clusters. But in the end, this is what most of your clusters look like. They're basically these unused, empty cars that are just waiting for consumers, right? They're waiting for resources to be used. Now, if I'm the CFO, this is a fundamentally problematic situation, because what I'm looking at, especially in really difficult times that we're in right now, how do I know that I'm going to be able to grow my environment when I look in the past and I say, well, my IT teams have been misusing their capacity for however long, and I'm still having performance problems? And you think, well, how can I have those two things together? Look, I can go at length and talk about how capacity is not a performance solver, but we'll really quickly touch on it here. So this is the n+1 by the numbers. If I took and I say from anywhere from a 1 to a 7 node cluster. Now, a 1 node isn't really a cluster. Thus, yeah, it's a bad situation no matter how you slice it. So if you take a look, what you're seeing now is at n+1, you're going to end up where you have a real problem if one node goes down, because the whole thing's gone. So if you're a 2 node, you're at 50% capacity and 33, like, you can see how the math breaks out. So that's really what it is. It's basically striping capacity across the different nodes, so that if I were to lose a node, then ultimately it's a 14% loss in a 7 node cluster. When you're doing enterprise architecture, if you're like going for a VCDX, something like that, or like the advanced, any advanced certification like TOGAF, this is a table that you need to be able to kind of know off by heart to be able to really rapidly calculate, because what you're doing is you're building capacity. But the problem is we build it with 5 years of guessing, right? So we have to say, I'm buying servers now. I have to make sure they last a long time. And this is why we call it the overhead tax, because what I'm doing is I'm going to take what I think we need, I'm going to double it, and then the person beside me is probably going to add another 10 to 20%. End result is you end up just with, let's say we've got a 6 node cluster and a 9 node cluster, and each of them are 66% utilized, which would be actually fantastic, because most places I walk into, nowhere near this, right? They're generally under 50% utilized. And look, this is expensive infrastructure. You can't return it necessarily, but you think about the long-term view. So if I've got a 6 and a 9 node cluster, what have I actually got, right? If I have 66% utilization between the two of them, what I've actually got is, look at that, there's 5 nodes between the two clusters that are 100% empty. So that's what you're actually facing, right? You almost have a completely empty cluster if you're at 66% utilization across these two clusters. So, right, this may seem like a long story to get you to what we're going to talk about, but this concept is incredibly core and important to how you think when we architect for superclusters. Because what you're going to do now is you're actually going to change things and imagine, what if I actually combined these resources together? Okay, I just did the math for you, so you know that now I have a 15 node supercluster. That's not hard math, right? 6 plus 9. Hopefully I did that right. There you go, 15 nodes, supercluster at 66% utilization. I know that I've got 5 empty nodes. The difference is that now those are 5 shared nodes. Because what happens if all of a sudden in that 6 and 9, 2 separate clusters, that your 6 node cluster suddenly goes to 80% utilization on a consistent basis, and it peaks a bunch of times a day? Well, there's nowhere for it to go. However, if you actually allowed for this bidirectional sharing of resources, now what you're doing, and thank you for VMware for getting caught up, and they actually for quite a long time now, for at least a couple major releases, they've had cross-cluster migration capabilities. So the cool thing is that superclusters in Turbonomic have been around since longer than I've been at the company. I've been here for 6 years, and when I arrived, I was documenting this use case that was used in production for a lot of companies. So let's actually look what it means, right? So now you kind of basically get the concept, and we want to go over the use cases we want to win with and why it's important to you and your team, your company, and especially to your CFO and your application owners. And ultimately, what's the result of this supercluster as we look at it, and we're going to build it right in the platform, right? So first of all, you get to repurpose extra hosts. Fantastic use case. I just had a customer that I was working through their environment, and I looked, and what they had a huge pile of hosts. In fact, I just did it on a webinar. If you want to go back to our resources page, then you can actually go and watch all the on-demand webinars. And it was about VDI. And the one particular use case is where they had all these different disparate clusters. I can't remember the exact numbers, but let's just say they had 15 clusters, and they actually compressed them down into 5 superclusters. And as a result, they suddenly were able to have all of these free and shared resources. So you get one cluster that's hot, one that's cold, one that's in the middle, right? You pool them all together, and you now have a lot of room for growth and performance. As a result, too, they couldn't get access to their physical data center. They couldn't deploy a new host. So they were stuck. They had a project that was completely blocked. What do they get? All of a sudden, they've got new hosts available because they were able to leverage the shared capacity. So this is true, that idea of a resource capacity pool. And thus, and with Turbo, we turned it into a performance pool as well. Licensing, right? So if you're using SQL, if you're using Red Hat Enterprise Virtualization, there's a lot of different tools that allow you to license at the cluster layer. And you don't need to be a lawyer to understand that this is not a place you want to be arguing with somebody over compliance. So imagine that if we had our 15 node and our 6 node cluster, if our 6 node cluster was a SQL cluster, well, but let's just say it's 80% unutilized. What if I could put workloads in there that are not licensed, and then if there was a constraint, then I would move the unlicensed workloads out. You still maintain legal license compliance, plus you get access to the untapped resources, and you still get performance gains. So it's a double win, and I'll go through that and how we do it. I call this elastic performance because that's truthfully what it is. So remember I said, if say you're 80% capacity for a while and then you peak, well, that means that applications are losing out, and so your applications are going to be slow. They're going to suffer. So now you can actually use those untapped resources. And I'm not even going to talk about scaling workloads. I'm going to purely talk about placement and moving them around. And ultimately, you can co-locate workloads. So that VDI cluster, same thing. The VDI webinar that I just did, it was another customer use case where they had VDI by itself, and it was really struggling. They didn't know how to expand it again because they suddenly had to be 100% remote, and COVID changed the way they access resources. So what they did was they brought the supercluster concept in, and now they could actually span VDI across all the different clusters, and they increase performance. And not only do they increase it for VDI, but for everything else without impacting other applications. So this is where the fun begins, right? You're going to say, this is great, but as they say in the Matrix, show me. So let's actually see what it looks like when you put it in action. So I'm going to show you a couple of different use cases in the platform. So what you're looking at today, for folks that are familiar, we've got a ton of great stuff coming up, and we've already got some good webinars that we talk about. So we're going to actually show you 2 different, as you may know, we have Turbonomic 7, which is a different scalable type of release, and Turbonomic 6. So we're actually going to show you in both interfaces how to actually do this and where it plays out. I apologize, it's a bit of an eye chart. I'll try and zoom in where I can. There you go. Hopefully you don't get vertigo from me doing that. So what I'm looking at right now is a very simple environment. So it doesn't need to be huge. You don't have to have massive amounts of clusters to win with this scale. And what I'm going to end up with is, if I go in, the first thing I'm going to do, I apologize, you're looking at the side of my head because I'm looking over at my other screen here. So if I go and I look across my clusters right now, I've got a few different clusters, and you can see this is the interesting thing, right? We've got some that are extremely highly utilized, problematic. Like if it's red, that means that turbo sees a problem. We need actions taken. Orange, same thing. The severity is lowering, kind of DEFCON 1, DEFCON 2 idea. And then we've got stuff that's yellow, so it's potential issues, and then green, we're good, right? So what if you looked and I've got an orange cluster and I've got a green cluster that are both used by my systems engineers. So what am I going to do? Well, I think the best thing I could do is maybe let them share those and pool those resources. So what you do is you go over to your settings inside your Turbo instance, and there's a couple of things we can do. But I'm going to show you how to turn on a supercluster. It's actually kind of crazy how easy it is. You go under policies, you say new placement policy. Again, I'll zoom in up at the top there. You can see new placement policy. Under your new placement policy, what we're going to do is we're going to type something. We're going to call this merge SE clusters. We have a merge cluster. Now, again, if you're fresh to the platform, you also, so there's placement. So this is a specifically set placement rules for a cluster. Don't place, which means anti-affinity. Don't let resources get placed into this area. So you can set restrictions. And we can show you how to use this in conjunction with your superclusters. And merge. So how do you actually create a virtual merger of clusters so that Turbonomic will now provide actionable decisions to say it's in cluster A today, and I can move it over to cluster B. And then the fourth option here is licensing, where I can actually say that I have a licensed virtual machine resource and a licensed host, and that by policy, we have to keep these together. But because it's dynamic and managed in policy, that means I can put other resources beside it, and licensed resources will never be allowed to move off of licensed infrastructure. So let's go to merge. We're going to say clusters because we want to merge our compute clusters. Pick your cluster. It's actually kind of crazy easy. Remember? Check, check. Okay, I'd love to say that there's a lot more to it. Select, save policy. That's pretty cool. It's almost anticlimactic. So what we've done is let's talk about what we just did. So we've created a supercluster placement policy. So that's only the first part of the activation. What you're saying is that these two clusters can be treated as one virtual pool of elastic resources. So that when I now have placement policies and other things around virtual machines or potentially containers or VDI instances, that they can choose anything within that merge cluster policy. So what do we want to do to maybe manage that a little bit more tightly? Well, what you can now do is we can group resources. So I'm actually starting with a blank instance, just there's not much here. The idea is that I can show you that from ground up. This is how easy it is to create. So there's a couple of identifying things that we want to do. We want to create, say, like a cluster group. We can use this for other purposes as well. So you go through, you say what kind of group type. I'm going to say cluster. I'm going to call it all clusters. And literally go through. You can have it be dynamic, so it can be dynamic based on names. So that means that if a new cluster comes online, it will automatically be added if it meets the criteria. I'm going to be super cheap, and I'm just going to take static here. So I'm going to, you know what? I'm going to glue them all in, and I'm going to say, you can actually just select. I could have been done it the easy way. So I'm just going to go through. I can manually select all of them. I can say dynamic. I can set it by rules. So this is my all clusters view. And this particular one, they're all on premises. Now, if you actually had them where you have a cloud presence as well, it may appear like it's a cluster, but it's actually not. So there's a couple of neat dynamic ways you can separate on-prem from the cloud, and I'll show you in a second. So that's it. You save a group. Oops. And why we want to do this is because, again, we can do other policies around automation. So first you identify, number one, identify your supercluster. So you've done that. You've created the placement policy. Now we create groups to identify resources, targets, and destinations so that we can put automation policies in place. So I could go through and let's create a workload group. So let's do a virtual machine group. I'm going to say all on-prem SQL. Now this one I'm going to do dynamically because I want to show you, number one, and plus it's just a better idea. So dynamically, I'm going to say select. You could do it by name. You could do it by tag. You could do it by a bunch of different reasons, hosted database engine, whatever you want. I'm going to say hosted application because I'm already discovering the application and it's regex. So I apologize. It's a bit of a review sometimes, but so I'm going to say everything that starts with and ends with SQL. So I don't care any SQL version, any SQL type. I want to include that. So now what I do is I go over here and I say apply. Now, what I'm seeing now is you'll see, obviously, there's some MS SQL. We may have some MySQL in there. There you go, some MySQL. And you can actually see the target that it's running on. So vCenter, 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 vCenter. Oh, okay. So remember I talked about how we want to separate cloud. So what we've got is this is actually a cloud SQL server. There's SQL running on it because it's inside the application. So we've got a few different things that are being discovered. So I'm going to very quickly go through and I'm going to add another criteria. So I go to my filter. I say add criteria. I'm going to say cluster. Oops. Not closet, cluster name. And here's my little trick of the day. Turbo trick of the day. Ding. I should have a little like icon that comes out. Tip of the day. .star. So meaning that if the cluster has a name, so even though in the cloud it looks like a cluster, it acts like a cluster, does not quack like a cluster. It is actually not a real cluster. So if you actually have a cluster name, that's a criteria that only occurs in a virtual machine cluster on either Hyper-V, OpenStack, vCenter, or a Red Hat Enterprise Virtualization. So there we go. We have a thinner list, right? And in this case, they're all vCenter targets. So now what I'm seeing is I go through, I save my group, all on-prem SQL. And then the same thing, we could actually say we could create a group for all Red Hat, or all Oracle SQL or all MS SQL. And then what we can do is then you also want to create your host groups. So I'm going to create, a set of hosts. And I can either, again, do it dynamically, or I'm going to call it SQL hosts. And I got to cheat just for the purposes of doing this quickly. I'll say it's these ones here. So those ones are, so we've defined those as SQL hosts. And again, this can be used now for other placement policies. Now, the other option we have is we could say by operating system, because let's imagine for a moment that our use case is going to be that I want my Windows servers to be able to move freely around everywhere they go. But I've got Red Hat Enterprise Linux, and it has to stay on my Red Hat Enterprise virtualization cluster because of licensing requirements. So you can't have your Red Hat moving around freely. So you can do it either by just a placement policy or by a license policy. I prefer, licensing where it's appropriate, but placement maybe, let's just say, maybe you can only set your Linux boxes to be in a certain cluster for some reason. So shout out to Ryan Chetty, who actually shared this great use case that gets asked for. So now what I'm going to do is I'm going to create, again, another virtual machine group. And remember, virtual machines can be part of multiple groups, and the tightest policy will apply. So all Linux VMs. So I'm going to say dynamic, and I'm going to say operate. Oops. OS. Best OS. Again, .star. So it starts with anything, has the word Linux in it, ends with anything. Of course, I happen to pick one where I don't have anything going on here. I have a Windows-only environment that I'm apparently looking at. So what you can do, but the idea here is, let's see if I've got Windows. Ha! I actually have no active VMs in my little tiny cluster that I'm selecting. Let's whip over here. We'll go to the second instance. It's like Martha Stewart's pre-baked oven. So under my groups here, there's a few more instances in here. So let's just log in there. So what we can do is we're going to say Oops. OS. There we go, guest OS. And again, simple criteria, either is or is not. Let's see if I get this right, hopefully. I hate to be made a liar of on a live session. There we go. Okay. So I've got 266 machines that are running Linux. So I could actually just say all Linux VMs, and I could define that. So it's dynamic. So every time a new Linux box comes online and you're seeing there's some on the cloud, there's some on-prem. So remember, I could go through to the same thing. I could say add where my cluster name equals present, basically. Anytime there's a present cluster name, that I'm only going to get on-prem. So all Linux VMs on-prem. And that's it. I could save that group, and then from that point on, I can actually use that for policy. And then same thing for Windows. You can either say is Linux, is not Linux, is Windows, is not Windows. It's your choice as to what you prefer as far as whether it's a true or false. So now what we're going to do is imagine that you take those criteria, and I'm going to go back to my first instance, right? So now what I'm going to do is I'm going to go back and I'm going to again go to policy. So my automation policy is where I'm going to ultimately end up, but let's revisit again for 1 second. Placement policies. Remember that if I set licensing, I want to say these are, the consumer is going to be virtual machines. So I can choose a virtual machine group, which I haven't defined because I didn't have enough virtual machines. And then ultimately it's either a licensing by host or by storage. So I can pick my hosts that are in there. And remember, so look at that. There's that group that I created that was all on-prem. So I could just create a licensed host group. Once you do that, then the turbo algorithm and the engine will only do placement in that cluster. If you move it, it will place it back if you have automation turned on, or you'll see an action in the action list to actually place it. Okay, so we've covered a lot. Let's quickly recap. Remember, what we want to be able to do is say, how do I repurpose extra hosts? Okay, so if I group these together and I allow workloads to freely move back and forth, then what I end up with is this kind of idea, again, where we had a super cluster, which now those resources are able to freely move around, so that if I had my virtual machine that I want to be able to have live anywhere, it can go here or here. So it can be in either of those clusters. And all of these clusters get treated as one virtual resource pool. And then the second use case that we talked about was, I want to create my dynamic group of virtual machines where I say this one, we're going to say it's Red Hat. Sorry, it's hard to write with a mouse. I should get it's easier than a trackpad though. Red Hat Enterprise Virtualization. And I've got Red Hat Enterprise Linux. Shout out to my friends at Red Hat. Love that stuff. So my Red Hat Enterprise Linux has to live on my rev. So it's going to get blocked by policy because I'm going to set a license policy, which is basically a virtual constraint. So that if I've got another machine that's over here that needs resources, and those resources are available not here, but over in the first cluster, it will dynamically place the virtual machine because we've got a super cluster created. It will move it. So just simply placement. We're not accounting for sizing yet. And then from there, if there's a constraint in this cluster where all of a sudden these things are all going red and there's a problem, you lose a couple of nodes, we'll dynamically move this virtual machine back out so that your RHEL instance is still in a safe, compliant, license, happy place, but you are evacuating other resources. And this is all done by policy. It's frighteningly easy, really. And that's kind of, why we wanted to talk about exactly what it means for us when we look in those two different instances. So what eventually will start to happen is I've created that supercluster. Then what I'm going to do is I'm going to go into my policies, and I'm going to set my automation policy. So I'm going to say virtual machines, and I'm going to say super cluster placement. I can set my scope by a bunch of virtual machines, by my supercluster group, whatever I want to actually identify. So I could have different policies based on different resources to allow them to either recommend moving, manual move, automated move. So you can select whatever you want. And then once you actually select your machines, so we just grab a couple machines, and then we set the schedule in which it can do that. All this is going to say 24/7, 365, all open. Action automation, I'm going to say that I want to be able to simply look about either move, potentially storage move as well, right? So I can be recommend, manual, automated, right? So I'm going to create this policy, turn it on, because I've got a super cluster enabled. I've removed the constraint. I've got shared network, shared storage, or even shared nothing migration. It's actually kind of amazing if you think about what we have in our environment. So in the end, what I really want to focus on for how do you do it, it's a couple of clicks. What do we get as a result? You get a lot less of this, and what you get is a lot more of this. So being able to make sure that we can dynamically use resources and that we can truly explore all of these use cases. And like I said, customer environments, we've been able to be successful. Scaling with VDI is really difficult. Do you want to build another VDI cluster? No, right? So what if I just borrowed the resources from another cluster? You've already got shared networks. And again, if there's ever contention, Turbo will automatically move resources in order to reduce and prevent congestion. So I won't go into the deep use cases and the pitch, but if you need any help and you want to learn more, you can always reach out. Now, this is really all there is to it. So I hope that it's helpful for you to be able to see that with a simple amount of time, you can look at your environment. And if you want to look in your architecture and say, look, am I building things like this, where I'm traditionally, looking at functional and logical alignment of resources to physical. So a direct physical to logical comparison. So I'm treating my logical web servers as a physical cluster. It's a good opportunity where we're seeing more and more folks don't have to do this. And look, hyperconverge was a great example. If you're using Nutanix, if you're using VxRail, VxRax, you really don't, you treat it as a true pool of resources. Well, you can do that right now. You don't need hyperconverged to do it. You just create a supercluster. You've got one pool of resources. And because Turbo will look for CPU compliance, availability of storage, availability of network, right? All of those constraints are automatically in the system. You don't have to program them in. You can if you want. So again, shout out again, Ryan Chetty, who's both a fantastic human, amazing services person, and just a good gent all around. He highlighted the use cases where we have one company that says, look, my Linux boxes need to stay in one cluster, but because of licensing, and yet I want to be able to use the resources without wasting them. So they got a chance to create, and again, unlock this idea of where I could go through and I could say, hey, what can I do where I can combine these resources and treat it as this truly elastic pool. So I hope that this is helpful. If you want to find out more, of course, you can go. This is going to be available on demand. You can reach out to your Turbo team. You can reach out to me directly as well. It's Eric Wright. I'm eric.wright at turbonomic.com. And we're always keen to be able to share stories. You can watch the blog. We've got a lot of great content coming up. So the one thing I'll double check to my good friend Chris, who's actually my co-producer here, just to let him know that we're ready to close up. And I hope that these are helpful. And again, here's my shout out. don't forget to join us on Thursday, it's 2 days from now if you're watching live, and I'm going to be showing you how to get started with OpenShift. This is a great rate to be able to like quickly spin up. We're going to use a mini shift, which is if you haven't already looked into it, do a quick looky-loo, and I'm going to show you how to spin it up from ground up, how we can very quickly and easily get this running up in a lab environment. And it's the beginning of a series. So if you go to turbonomic.com/labs, then you're going to be able to see a lot of resources that we're creating and making sure that we can enable you with better ops and developer advocacy. So making sure you understand we can expose how to do some neat things with the API inside Turbo, or just in general, how to use Kubernetes, how to use other tools. So very, very cool. And then what we're going to do from there is be able to go through and kind of build on those use cases. So there'll be iterative use cases. So Thursday, I'm going to feature how to spin up a very simple development OpenShift environment. So you can start testing OpenShift. And then as we go through the series, we're going to see how to deploy resilient OpenShift environments and a hybrid deployment. And I got to give another shout out to somebody who's in the community, JJ Asgar. If you don't already know JJ, he's a fantastic human. He came and he actually helped us with our Turbonomic live event, which we did recently. JJ is a developer advocate over at IBM, and he does really, really great stuff. So he and I are going to be hopefully working here, doing some things. We've been doing some stuff over on the IBM channel, and look for some more blog content. So making sure that as you think about your Kubernetes journey and your container journey, that you can really easily spin up and test out OpenShift. So with that, I'm going to start to wind down. I do want to, again, thank everybody for joining us. This is a fun way for us to be able to share and learn together. I hope that you find this helpful. It's been fun sharing our supercluster journey. So if you want to get started with your superclusters, go in, check it out. Reach out to your customer success rep if you need help, and we will definitely make sure that we're ready to go. With that, we're going to close up for the day. Thank you for watching Turbonomic Labs Live Edition. My name is Eric Wright. I'm, of course, at Disco Posse. If you want to connect with me on Twitter or look for me on LinkedIn, just search for Disco Posse. Trust me, there's only one. And with that, we're going to finish up for the day. Thanks, everybody, and have a great day.